Okay, we're here in the last section for chapter 6, and it's going to remind us about inverse functions. So you know about inverse functions from both intermediate algebra and ideally your trig class, certainly your trig class, because you would have had to do inverse trig functions. So inverse functions go in the exact opposite way. So if you remember, the sine function um, takes an angle and maps it to a number between -1 and 1. The inverse function takes a number between -1 and 1 and maps it to an angle. And so um, what we'll notice though is in order for that inverse to be a function itself, we have to be 1 to 1. And so what he's showing right here is a segment, this blue segment right here is a segment where the graph of sine is 1 to 1. 1 to 1 should be a familiar concept to you, meaning that there's no y values repeated in there. And so from minus pi over 2 to pi over 2, we get a 1 to 1 function. We have to define our inverse functions only, well, they can only be defined on 1 to 1, otherwise they wouldn't be functions. If you look at your cosine spans from -1 to 1, from 0 to pi. And so that's going to be its cutoff of its domain. Tangent, minus pi over 2 to pi over 2. And then you can remember the other ones because of how they're related. Cotangent, sorry, cotangent is, remember, cotangent is cosine over sine. And so it's going to be totally related to cosines 0 to pi. But they're not including the endpoints because they're asymptotes. Secant's the flip of cosine, so it's also going to be a 0 to pi, but you can't have pi over 2, so they'll rule out the pi over 2 that's in the middle. And then cosecant's related to cosecant's related to sine, and so therefore it's going to have a minus pi over 2 to pi over 2 end. And so all of this should be familiar, but we're going to come and talk to you about finding the inverse function. So they're doing the graphs of them. So this is the sine function from minus pi over 2 to pi over 2. This cutout of the function is where it's 1 to 1. They'll always choose a region where it's 1 to 1 because there's lots of regions, but that is centered about 0. So if you want to find the inverse function, you'll rotate minus pi over 2, and then that is what gives you the arc sine. And so notice that the arc sine or sine inverse goes from -1 to 1 and has outputs only between minus pi over 2 and pi over 2. We cannot stress that enough, that the arc sine has a limited output. And same with any of the inverse functions. And so arctangent, all of that. And so he's just going over the graphs. So here's the tangent graph, goes up and down forever, but we're turning it on its side, and so you can get this function right here. And so he's going to go to the graphs of the 6 inverse trig functions. This is the graph of sine x again, and then the inverse function would have a range. This is the most important thing. It's often forgot about. The range for arc sine, which is also sine inverse, he uses both symbols in the homework, is from minus pi over 2 to pi over 2. You want to memorize that. The inverse for cosine, right, is we got to cut it where it's 1 to 1 or from 0 to pi. And so that's the domain and range of the cosine functions. So you know the inverse functions, right? Cosine inverse of x, arc cosine of x. There's a reason why it's called arc cosine, because it's related to arc length. But and same with all of them. There's a reason why they chose arc as that. So the domain is the old range, and the range is the old domain. So what do I mean by that? Well, let's look really carefully. The domain of the cosine is the range of the cosine inverse. The range of the cosine is the domain of the cosine inverse function. That's definition of an inverse function, just like you had in intermediate algebra, right? And you guys are awesome because you picked majors which we knew that you would pay attention in those classes. Some in an intermediate algebra class don't care because they're not a math major, but you guys were, so you paid attention to all of that. And so the domain is from -1 to 1. Obviously, you couldn't put anything in there. So let me give you an example why we're here. What are we saying? And that might be really good. So what we're saying is you can take the inverse cosine of anything. So inverse cosine is either written as cosine inverse or arc cosine. Now, not just anything, of a number between 1 and -1, because let me just make up something like -1/2. So if we're going to look at the arc cosine of -1/2 or the cosine inverse of -1/2, that is the same question. What we're asking ourselves is what angle gives us -1/2 when we take the cosine of it. So this thing is looking for the angle. So you and I have memorized that cosine of pi over 3 is 1/2. And so we know it's a pi over 3 reference angle. Now, if we start saying this to ourselves, apologize. There are two places, right, if we go from 0 to 2 pi, where cosine's going to be negative. And that's a problem for a function. It cannot have two answers. And these are inverse functions. So what we're saying is you have to limit your view between 0 and pi for cosine, because everybody's going to include the first quadrant. So it's the first quadrant. Now we couldn't include the fourth quadrant because cosine's still positive there. So it's from 0 to pi. And so you're looking for a second quadrant angle that has a pi over 3 reference angle. Easy. 2 pi over 3 is the only answer. You can tell me all day that negative pi over 3, the cosine of negative pi over 3 is negative. That's right. And the cosine of 5 pi over 3 is negative. That's right. But the cosine inverse function can only spit out between 0 and pi. Let me stress that up here as well with the sine inverse. Let's do the same thing. Sine inverse of -1/2. Well, you have to respect its domain and its range. So I'm definitely in the domain. Sine inverse of -1/2. Well, sine is negative in the second quadrant. Oh, apologize, not the second quadrant. Let me erase that. Sine's negative in the third quadrant and in the fourth quadrant. Well, we can't be naming the angles like so we know for 1/2 has a reference angle of pi over 6. That's what we've been working on. So I cannot say that it's 7 pi over 6. And I really can't even say that it's 11 pi over 6. I can't just name any third quadrant angle or fourth quadrant angle. I got to name something in the range. And the only thing in the range is negative pi over 6. You can tell me all day that 11 pi over 6 ends up at the same place as a negative pi over 6 in terms of a circle and going around, and you're going to have the exact same cosine and sine. It won't work. You have to name answers that are within the range of minus pi over 2 to pi over 2. So respect that range is the key concern there. So they're just going to go through and look at tangent, right? And the range of tangent. Now tangent has sine up top. And so it's minus pi over 2 to pi over 2. And he's just duplicating information here that you can read. Cotangent is related to cosine and therefore has cosine up top, and therefore it's from 0 to pi. And then he'll do the secant and the cosecant. So really it all comes down to you memorizing, and it really has to be memorization, that sine x, sine inverse of x, can only spit out between minus pi over 2 and pi over 2. Nothing outside that range. Okay, cosine inverse of x is from 0 to pi. Now if you ever say, well, how am I going to remember that? Well, there's a few ways to remember that. You could do what Joe did in the very beginning and draw a picture and realize, oh, sine can't be from 0 to pi because it's not 1 to 1. This must be the minus pi over 2 to pi over 2 cut. And it is. Then with cosine inverse, it looks like this. And you can realize, oh yeah, cosine's cut from 0 to pi. Wouldn't be from minus pi over 2 to pi over 2. Once you know those, you know everything. Because tangent inverse, tangent sine over cosine, and so it's related to sine. It just can't include the endpoints because it's undefined there. Cotangent, no problem. Related to, it's related, well, it's cosine over sine, so it's related to cosine, and so this is 0 over pi. So if you can just memorize the sine and cosines, you'll get the other ones, because you'll know cosecant inverse of x is related to sine, and so that's from the minus pi over 2 to pi over 2 area, right? And then secant inverse is related to cosine, and that's from 0 to pi coming through as well. And so we'll see that, right? Domain and range of the arc secant. So, yeah, 0 to pi with, you can't be pi over 2 in there because it's undefined at that point in the middle. And so we're getting the whole range of values coming out. So that's what we want here, is just a picture of it. I do not believe you have any questions about graphing though. The graphing was only to justify the range outputs. So this is only as a background to do the real 6-5 work that's going to, or 6-7 work that's going to come in the next section.